So our next talk in the block is by Hana. She's going to be giving a talk called Plot Devices, Tools for Better Data Visualization. Everyone give her a hand, please.
Hi everyone, my name is Hana, and I'm a software developer at A-Flight. But in my former life, before I entered the tech industry, I was a scientist, and I did research into genomes. A genome, for those of you who don't know, is the set of all the genes in your DNA. And the problem with genomicists is that they make really bad data visualizations. So this was a pet peeve of mine with every paper I read. We frequently got figures that look like this wonderful network on the left. The official term for this kind of figure is hairball. I also saw a lot of heat maps like this. This shows gene expression data, but you look at this and you go, what am I supposed to get away from this? I believe that effective data visualization should tell a story, and it should make that point clearly. But that's easier said than done, especially when you're working with big, complex data sets that have a lot of variables, and you want to reflect all the relationships between those variables. And one of the things that I came across that really changed the way I thought about this problem was this concept called grammar of graphics. So this basically means that you have a framework of useful abstractions that you can apply in successive layers so that you can build a data visualization. And this makes it really easy not just to think about how you're representing your data, but also to explore a wide space of how you can visually represent that data. So these layers all sort of begin, first of all, with the source data, of course. And then you can think about what shapes you're using to represent those data points, be it a point, a line, a bar. This will affect what kind of chart you create. Then you can also think about how you're representing this data. It could be position along the X or Y axis. It could be color. It could be the size of your shape, if you want to have that correlate to your value. You can even present multiple related plots, which a lot of these frameworks call facets, on the same plot to make it easy to represent extra dimensions. There's also statistical transformations that you can apply to your data, like mean, sum, binning for histograms. And then finally, there's all these details of layout, like what your axis limits are, what labels you use, how you annotate your chart. So there are several data visualization libraries that are available that apply this concept to this concept of grammar of graphics. The first one that sort of really exposed this idea to the world is ggplot2. Now ggplot2 is a library in R. Those of you who are software developers probably haven't really dealt with R before because it's mostly used by statisticians and academics, but it's very popular there. And within the R world, ggplot2 is probably the dominant data visualization library. With good reason, because it makes it super easy to create beautiful plots like this. So for this, I'm using a data set that I got from the CTA. It's basically the daily entries at all the stations on the L from 1988 to 2018. So that's a lot of data. Here I've separated it by the different lines, so and color-coded them according to which line it is, and showed what the distribution of these daily totals across all the stations are. It's on a logarithmic scale because there's a lot of variation among the different stations, as you can imagine. And you can sort of quickly see that the red line and the blue line have the highest number of station entries. And what I want to point out is just how easy ggplot2 makes it to generate a complex plot like this. You just feed it your data, then you specify which variables are going to be shown on the x and y axis. You can you also specify that different L lines will be separated by color, and then you just say that you want to make a box plot. And then you apply changes like saying, oh, I want the y-axis to be logarithmic instead of linear, and make sure that the colors match up to the same colors as the name of the line. And it's also easy to visualize this data in a completely different way with just a couple of changes. Now we're looking at the maximum daily station entry across the years and separated by line. I thought this was a fun plot to show because you'll see that in 2016 there was a really high maximum station entry on the red line, which I figure has to do with the Cubs winning the World Series. And as you can see, like it's very simple to, for example, just take the maximum of the daily station entry points using this stat summary function. And this is yet another way of visualizing the data. This time I've plotted across several facets, which, as I mentioned earlier, are related plots that you can put together in a figure. In this case, each facet is a different line, and you're seeing in the bold line the average daily station entry across different months of the year, so from January to December. In like slightly paler lines, I show what it is for each station that's on that line. It's sort of interesting that most of those stations follow the general trend as the mean line, but there are a couple of stations that you can see sort of break the trend. So this is something that you can look into further in your exploratory data analysis. And again, I want to sort of point out that generating these facets is just an extra function called facet wrap in this case. So it makes it really easy not only to create the visualizations, but also just use it to explore your data and find new stories to tell from it. The other library that's come out recently that applies the same grammar graphics approach is Vega Lite. And I got really excited about this because, first of all, it's a declarative language that's based on JSON. So you don't have to use R to take advantage of it. It has bindings available in Python, Elm, Julia, Scala, Clojure, and JavaScript. So you can pretty much use a wide variety of languages, anyone that's your favorite, to implement this specification. And one thing that's really neat about Vega Lite is that it not only allows you to build these complex figures, but you can also make them interactive. So this is an example of what one of the JSON specifications look like. Even though the syntax is a little different, you can see it sort of takes that same approach. You specify what kind of shape you want to represent your data as, and then you specify which fields are represented on the x-axis, y-axis, or by color. So the static version of this plot is here. It's the same max daily station entry over years that I showed earlier in R. If you want to see the interactive version of this, which I couldn't get to export to my slides correctly, but you can see here I have a little drop down that allows me to select the line and just highlight that particular line value. So this interactive element, I think, really makes Vega Lite powerful and allows it to do some things that you can't do with just ggplot2. Sort of as another example of that, This is another JSON specification for a plot. This time it's actually separating by a field called day type. That's just to distinguish between weekends, weekdays, Saturdays, and Sundays and holidays. And again, the static version of this plot is here. But the interactive version allows you to sort of zoom in on the scales, and you can see that each facet in the plot mirrors each other in parallel as you zoom. One of the things that I find interesting about this plot is that apparently there's always a spike in writing the L during the months of September to November, so I guess we're right now in the peak of L commuting season. So if you want to read more about this topic, the term grammar of graphics was first coined by Leland Wilkinson, who published a book on it. Also, Hadley Wickham, who is the developer who created ggplot2, has a very nice paper explaining what this approach is all about. And also the ggplot2 and Vega-like documentations are pretty comprehensive and should give you all that you need to get started. So I hope this means that all of you will go home, stop using Microsoft Excel to generate your graphs, and take a look at one of these. Thank you.